Hello, nice to see you again for another streaming. Today we'll talk about Heaps game framework, which is a game framework I've been developing for creating games at Shiro Games. So, well, let's get started first by explaining a bit what Heaps is about and how you can use it and what are the specific features compared to other frameworks you can find uh, in other in Axe. First, I will show you the website for Heaps. Right now, there is no dedicated website yet, so you have to go on the GitHub page, which is ncanas/Heaps. Here you will be able to find and download the whole source code. So it's entirely open source. In Heaps, you get different top-level packages. You get H2D, which is a 2D package for doing all the 2D display. You get a 3D package, H3D, for all the 3D stuff. You get a HXD for all the cross-platform things, events, or file formats, or resources. And you get also HXSR, which is the shadow language for Heaps, which is embedded directly into the engine. And you get the samples directory. In the sample directory, you have a fair amount of samples showcasing various things such as 2D samples, some bound checking, drawing things, filters, even the things such as networking or advanced rendering such as shadows or SAO, which is ambient occlusion or skinning. You have a lot of different samples available to look at. So let's get started. We will open Flash Develop, Xdevelop actually. It's no Xdevelop. And get started with a small Heaps sample. So I will create a new project. Heaps is a gaming framework. So it's been entirely developed to make games, and the main goal of Heaps is to create 2D or 3D games that are optimized by the GPU, which means that when you write a game in Heaps, you don't get the same control you will get in other frameworks. For instance, you don't get control over how the pixels are exactly rendered on the screen because you're rendering using the GPU, which means you don't have a direct access to the memory buffer. You need to create, Heaps will create triangles for you to display even 2D scenes, but you get benefits of having full access to GPU optimization and acceleration. So the whole engine has been designed to be GPU friendly. So the whole API is built so that when you compile for GPU, you get the best performances, and you can do some things such as batching to increase the amount of things you can show on screen. Right now, the engine is written almost entirely in pure X, and so you get only a few classes which are platform specific, which are mainly the driver class, which is a 3D driver, which gets implemented in different platforms using either GLCell or Stage 3D and Flash, or maybe DirectX later. And also you get some, of course, abstract class for events like mouse, cursor, like a mouse, keyboard, and gamepad. And you get also another like platform-specific things for, like resizing the window or this kind of thing. So you have really only these three. I mean, like the notion of stage, of having a window, the notion of events, and the notion of graphics driver are platform specific. Everything else is entirely written in Axe, and so it's platform agnostic. So actually adding new platforms to Heaps is pretty easy and pretty straightforward. So it's a very highly portable framework because it doesn't have that much native part to implement to work in on other platforms. So at the moment, Heaps supports several targets. We have the first target we made was a Flash target using Stage 3D, which is a 3D API for Flash. And the second target is a JavaScript target using WebGL. So we don't have non-WebGL support using Canvas fallback because we are doing a lot of use of shaders. So if you don't have WebGL support, you can't run Heaps content because it's really designed to run on GPU. So that's one limitation, but on the other hand, you get very good performances. We have an experimental Haxe CPP target for Heaps, which use SDL for rendering. I think it works pretty well, but there's still issues at the moment with the sound. Only sound is not perfectly supported at the moment. And finally, like some people from Motion Twin, which is my past company, they are using Heaps, and they published support for Lime, which is a low-level rendering of OpenFL. So you can also use Heaps with not OpenFL as a whole, but with Lime, so only a part of OpenFL. And I guess you should be able to render OpenFL content on top of, or mix Heaps content with OpenFL content, or soon maybe the not advised way of doing things. And that's it for now. I'm currently working on new targets for it, which should maybe use DirectX in the near future, and console support as well. I have PlayStation development kit, and I need to port our game Evolon 2 and 1 as well on PlayStation. So we will work on this in the upcoming months and make sure that Heaps run perfectly on the PlayStation 4 and 3 maybe also, and later Xbox and this kind of other consoles. So yeah, so that's for the presentation of the project. So let's get started with some code. We'll open a new example. Actually, we have one open already. So Heaps is made using a 3D you have basically, when you start an X example, you create a class and you extend HXD app. HXD app is a base class for any Heaps application. So you still get your main, you get control over your main, like you do in Haxe usually. So you get a function main. So you when you compile, you say I use Heaps. You can define a resource path, which we'll look afterwards, which is where your resources are stored. If it's by default, it's in the local res directory. But if you have a different directory, for instance, here we are looking in the upper directory res because we have resources in commons for all the examples. And well, you can do a lot of different things. I don't need this here. And here you have like an example. So you just need to compile with -lib Heaps basically, and it works out of the box. So here we will initialize the resources, which I will come back afterwards, and we start the application using new main, and that's it. And here we get a few overrides that we need to implement. The first one is init, which get called when your application is ready for initialization. So you can actually create your scene, your 2D and 3D scene, and set up everything, the materials and everything. And the other one is update, which get called with a small dt, which give you how much speed the application is running. For instance, if you run at 60 FPS, which is the default target, you will get a DT of 1, and it's run at 30 FPS, you will get a DT of 2. So this way you have, for instance, if you move something on the screen, you just have to multiply by DT, and it will move at the same speed, whatever the actual speed of the rendering, the FPS of screen. Because if, for instance, if you have a screen which has 120 FPS, you get a DT of 0.5. So you can, like this, you can have all your things moving accordingly at the same speed, whatever the refresh of the screen. Let's back to the init section. I'm looking at this. So here we will start creating a new cube, which is a primitive. So in Heaps you have a primitive and instances. Primitives are shared between instances. So you can create, for instance, one primitive of cubes and have a lot of actually a mesh for this primitive. Actually, this is what we are doing here. So we create a cube, which by default we have the size, which is x, y, and z. It's a cube by 1 by 1 by 1. We translate it by -0.5, so it gets entered into the 0. Here we index its vertices, which means that instead of having the normals like pointing out of the cube, we get really hard faces. We add the normals and we add the UVs, which is the texture coordinates. Here we have this is a resource manager for Heaps, which is, I think, pretty neat. Basically, you get a class hxdres, and when it's macro based. So when you start accessing here, you will get actually access to custom font, hx logo, normal map, TrueType font, which are actually the file which are part of your resources directory. If I open, where is it? Can I open maybe from here? Well, I don't know why it's installed. So anyway, if you look at the directory, you will get, if you put a file into the resource directory, for instance, hx logo, you get actually, it's a PNG, so you get this 2-bit map to texture or to tile, which are the possibilities you can do with a PNG. So you get a 3D typed resources, which is if I remove the hx logo PNG file, or if I rename it, my source will not compile, and I have to fix this, which is really neat when you want to reference some resources statically in your code. You make sure that it's correctly compiled, and it's actually a PNG because you can use toTexture to it. And you get auto completion, which is great also. If you have directories, for instance, if I have my textures, I will have something like this for texture to texture. So I use dot syntax to move to look into the different passes. So and here I'm creating a mesh material with a texture, and I create two cubes. The first one it takes the primitive, the material, and here S3D is which scene. It's the parent of the object. So it's actually the scene. S3D is a scene we are adding to. So right now we have in X6D app. Every app has a 2D scene and a 3D scene which is already created. So you can add things directly to the 3D scene or to the 2D scene. And I create another cube, but this time I create a new material. I don't assign a texture. And here I will change the material color for this cube. And I change this coordinates, and I scale it a bit down. Here I create a light, which is a directional light with this direction, and I adding it to the scene. I activate the specular of the lighting, and I change in the light system. I put an ambient of 30%, so you have like a small ambient light and a direction light, which bring you additional lights. And I enable the lights on the cubes. So this is a small setup. Well, it's a lot of steps, but usually when you have your own game, you can factorize that using a few methods to load the texture, create a material, and everything. Here I can update on the update. So this is init is done. So we have initialize our scene. We have put 2D and 3D two cubes and a light. And in the update, we will change the camera position, making it rotate around some axis. and we will also rotate the cube, and that's it. So if I start the example, right now I'm running on Flash, and you can see first cube. So you have the camera which is turning around the scene, and you have another cube here displaying. So that's the first example. So Heaps can do a lot of, actually, a lot of things more advanced than that. So if we look at the examples, which should be there, I don't have all the examples here, I guess. Where is this stored actually? Recent projects, Heaps, projects, Heaps samples, projects, Heaps samples. Okay, we have all there here. We can open, for instance, the skin sample. It's opening with Flash develop. Okay, I have to do a few setup for next time. And okay, the skin sample is pretty much the same, but this time we will add a FWX file, which is a 3D format. So if I start, it compiles, and so I will display some 3D models, some real 3D models that have been actually built for that. Oh, it's trying to build. Okay, it's trying to build for multiple platforms. So here I need to build, I guess, only the Swift and execute. Okay, that's something else. I don't want that. Yeah, sorry, it's just I didn't check everything before starting. Okay, here you have another example, which is a model we had in Evoland. So you have this 3D model with skin animation. It have a sword, and you have like these shadows which are calculated and in real time to display over it. So how do you do that? I will remove this part. It's even smaller, like in it than previous example. Here we have a model which is in our RES sources. We have a model.fbx, which is the 3D export format for many 3D editors. We create two HMD. HMD is the internal Heaps 3D format. So basically, when you have a FBX is a really EV format, really hard text time to parse. It's not binary. We are using FBX in text version also, so it's not binary. It's so we first have a conversion going on in to HMD, which goes into the temp file. So into the temp file, we get a model.hmd, which get created. And if a model FBX change, it will reload and rebuild it. And here we have this primitive, which is load, and we will create an object with it, saying, okay, I want to read an object with from this HMD, and I will give this callback to load the texture. So the load texture will just load. We just do that. It will load. It will get only the core name of the texture and load it dynamically using our resource loader. And here I scale it a bit. I add it to the scene. I change the camera, and I can load an animation from my store into my HMD and play it. And I create a directional light. And for the materials, I will set up a few variables, disable the curling. For shadows, I just need to do that, saying shadows equal true, and that's it. And here I have some other like ambient light and settings for the shadow power, which gives you how much the shadows should be, shadow strength should be. So you have a lot of control about everything in the engine regarding the shadows, regarding the whole engine has been built so that especially the 3D part, so that it's entirely customizable. You can create your own path because it's a multi-path system. You can add your, for instance, here I'm getting the path shadow, but I can add custom paths. I can redefine entirely how the rendering is occurring using multiple render texture all the features you can have for like kind of quite modern 3D engine. So basically it's really a framework on which you can build on if you're interested into like developing 3D content in quite high level, high quality game. But also it's simple enough to use as a first start if you just want to make, if you want just to make the game and you're not interested into the technical details. So that's for like the 3D things. We can look at other examples afterwards. I want to show you a bit the 2D, of course, which is pretty easy as well. And then I will show you also. I will also show you. Okay. How you can create custom shaders, which is something really great about Heaps as well. So here I open the 2D example. So that's exactly the same. Instead of creating a H2D scene, something a cube or mesh, you create a H2D sprite, and you say this is the sprite I added. The parent is my S2D, and I change this XY coordinate, saying I want to place it in the middle. And then here I create the same logo, the same texture, but instead of saying two texture, I use two tile. In Heaps, a tile is a part of a texture. So, for instance, if you have a tile set with a lot of different texture, you split it into a grid, into different tiles, and you can each 2D actually element can reference a different style, but they still share the same texture. So, if you look at the tile API, you get H2D tile. You get a lot of things. You get XY with X8, and you have also a pivot here that you can define to say, for instance, my pivot for my tile is at the bottom, middle, and not always in the top left, which help you like not having to all the time. Yeah, for instance, here we changing the tile to the center. So this way, when we rotate the bitmap, it will rotate in the center of the tile. It will not rotate on the top left corner. So here we create 15 of them with a different position and alpha transparency and a blend mode to additive. We also created a two-type font that we built. So Heaps has support for two kinds of fonts. The most cross-platform one at the moment is bitmap font. So you create a bitmap and you give it all the characters. You have tools to export that, and you get a bitmap font. So it's perfectly render perfect, but you have to export a bitmap for each font size you want to use. So the one is to use a TrueType font and build the font using a given size. And here I create an H2D text with this font. I change the text color. I had a drop shadow. I set the text, and I put it on the and then I have a custom font. So here custom font is using two fonts, so it's actually a bitmap font. And here I'm using build, which is a building. This is a TrueType font, not a bitmap font. And here I'm using, again, some kind of displaying. Here's an event also interesting on resize. You get this event triggered if the screen is resized, whatever the platform you're running on. So for instance, on mobile, if you turn this, you will get, okay, I have to disable this right now. Let me just. I think that's it. And if you run the example, here you get all these X logo, which are displayed on additive, which is two font display. This is like bitmap font, and this is a TrueType font with a drop shadow, and well, that's it. So you can see it's nothing really fancy. Just you create sprite, you get texture from your resources, and you add it to the scene. Just back to the resources, you see at the bottom in my main, I have something which is hxdres init embed. You have a lot of ways to initialize your resources. The way it works is as you have a resource loader, and resource loader is actually pretty abstract. It have a load function, exist function to check if some resource path exists, and it have a file system. And the file system, actually you get a tree of files, and it's entirely a virtual file system. So it means that depending on the init you're doing, so you have three right now: init embed, init local, and init pack. You will get a different file system implementation. So if you do, for instance, init embed, it will embed all the resources in your res file as resources into X. So it will embed all, depending on the platform it will use. For instance, if it's a Swift, it will put into the Swift. If it's JavaScript, you get one very big JavaScript file with all your resources embedded in base 64, etc. So it guarantees that you use X native, like X resources management, to access the files. So of course you cannot modify them because they are in memory, but you get access to the whole to all of them as a file system. If you use, for instance, init local, so this is only supported if you're using a file system like sys targets such as hxcpp or Flash using R. So it's not supported in JavaScript right now. It will use the local file system to access your resources. So it will look into the resources directory, and it will read files from here directly. And when you use init local, you can actually enable something which is nice, which is I think it's there. Yeah, you can use hxd res resources dot live update equal true. When you enable live updates, it means that for a lot of different of your resources, for instance, the image or the textures, not the 3D model yet, but we are working on it, and the sounds, and even a lot of your custom things, you will be able to they will be refreshed automatically if they get modified on the hard drive. So it's really nice to be able for your graphics people, for instance, to get a real-time update on the resource when they get modified. So when I actionate live update, for instance, if I have a resources, for instance, I get res dot let's say custom fonts, I can use watch, and here I get a callback which is when live update is enabled, and when the callback will be called if the file is modified. So you can actually implement your own resource reloading for your application, saying I have some data stored into some file, and if this file is modified, I want to refresh things on the screen. So you just have to write this, and you get a callback when it's modified, which I think is pretty neat too. So that's for the resources management, H2D, H3. Let's look a bit at the shader system, which I think is pretty interesting. Maybe I can open some other example for that to show you, which would be good. Let me think. Well, this one is used. This is another example. Maybe let's look into that. This is an SAO example. I will first show you what it does and how it runs. So here you get a lot of cubes, and you get this like ambient occlusions, which is entirely runtime calculated. So there is no texture. If you move the cube in real time, they will update accordingly. And this is made using a full screen shader. It requires a lot of calculations because you need to have a depth map for the whole scene and a normal map for the whole scene as well. So here in the material, we are using adding a new path, depth and normal. And we are using a custom renderer. So this is just controls for the screen. We are using custom renderer, which extends scene renderer, in which we can actually customize, saying we allocate a target texture, we select it, and we apply the shadow, the SIO effect on this different texture, and then we blur the results and we multiply the results. So while this is just some kind of way to customize the whole rendering of the scene, you have a lot of easy possibility to do that. So, and for instance, a shadow example. Actually, maybe I don't have one, but I can show you a few other things. Another example, which is world. Okay, this is just an example of building really large. I don't have control on this, mouse control, but really large walls. We have something which is a way to create a wall which is spliced into chunks, and it's very easy to use. You can use like thousands of elements, and then we get rendered into just a few calls. So here we are dealing a lot of rocks and trees on the ground, and that just get everything gets done, like, and you get the shadows also calculated. So there's a lot of things that we don't have a texture for the ground, and you can imagine a lot of things, but it's running very well. You can see because it's not animated, but it will run in the runtime even with very large walls. Well, let's try on this one, maybe not on this one. I will try on the cube, which is really interesting. Let's try to use a custom shader, to write a custom shader and add it on our cubes here. So here we are creating a lot of cubes and creating a mesh for it. So here I will create a new shader. So a shader in Heaps always instance. So I will create custom shader, and you instance HXSR shader. Okay. And once you have that, the only thing you have to do is to create a static var source, which will be the source code of your shader. So let's try something saying, okay, function vertex. Here we want to have a shader that actually works on 3D model, so we can actually extend directly use import. So this is an import, but use metadata to import into the source, because you cannot use import here. So it uses some kind of metadata to say, I want to import here my H3D shader base mesh. So it means that I get all the definitions of base mesh, which you can open if you want, saying, okay, I have a camera, I have an input position normal, and I have all these variables that I can use to modify my my geometry. So here we will do that, and here we will do, for instance, so it's an input position, which is a maybe not the input position, we cannot modify it. This is a relative position, plus equal dot z plus equal something of cosine of relative position dot x plus global time. Okay. Multiply. We can do this kind of cosine or sinus animation using this, for instance. Okay, that's just a way. I'm just offsetting the z position of every vertex based on some like functions that evolve over time. Okay. So if I create this shader, so this will get compiled by HXSR as a really very complete shader. So, but first I need to add it to my mesh. So here I create my mesh here, and I will access its material. Material is contains a lot of things about blend mode, everything, and I can access its main path, which is the path that controls the rendering, the main rendering, and I can add a shader, say new custom shader. Okay, so and here you can see all my cubes are actually animated in real time. They are quite synchronized actually. Maybe we should, because they have the same global time offset actually. So how could we make not them synchronize? Maybe because our offset is too slow, too low here. If we do that, this is well also. If we change this, oh, that's a bit too much maybe. So this is entirely calculated by the GPU. Actually, you don't need anything to calculate here. So what Heaps does, or what HXSL does in this case, is that it will look at all your shaders that you have in your code, because here we have different shaders happening on the cubes, and it will actually combine them. It will compile each of them separately and combine them together into a single shader, because that's the way the GPU works. You need a single shader for your models. But it also makes sure that when you have different objects using the same combination with the same somehow parameters, the same like not the same dynamic parameters, but the same constant parameters, it will also like share the shader between the instance, so it doesn't get recompiled all the time. It only gets recompiled if it changes. So that's something really powerful in Heaps, is that you have a wall like shader framework that you can customize to build really a wall ecosystem. Actually, in Heaps we have quite a lot of shaders already. If you look at the S3D shader, we have alpha map, we have base 2D and mesh, which are the base shader for 2D and 3D. Here shader for bloom. So you can say shaders are a very small example of a small piece of code which just do some kind of calculations. But I think the great things about X is that you can actually combine them together in a framework which are using HXSL, which also will do a lot of optimization to make sure that the shaders, the not used parts are entirely removed, for instance, that a lot of calculations doesn't get done twice, etc., etc. So that's, well, that's, I think, that one of the main things I love about this engine. Okay, I will answer a few questions in the chats now. Okay, what is the performance cross-platform capabilities of Heaps? Okay, so, well, I guess, well, I already answered to that. We have support for Stage 3D. We have support for WebGL and a few other platforms as well. Is there X TrueType font renderer in there, or does that use some Flash functionality? Yeah, well, we don't have a complete TrueType font renderer for Heaps. We use the native one when it's available. I want to see performance in WebGL. Okay, well, we can also take, okay, this example with the shaders. We can actually open. It compiles. I think at the moment it compiled to JavaScript and Flash. Yeah, that's it. We have a next here. So instead of launching the Swift, I can launch the index, and we can open with not Edge. Let's try with Chrome, and I will open it there. And it's not working. This is always samples not working when they are supposed to. Let me check if something to do. What is to do? Okay. Yeah, there's some. It's trying to use MRT. Okay, I have to disable MRT for now. Um, I think MRT is not yet done in JavaScript. No, I say Chrome. I did remember saying, oh well, it works on Edge too. So this is a WebGL. So this is entirely like WebGL example, the same example running in WebGL in real time. So you can see I didn't make any change in my code except fixing the MRT thing. And that's pretty much that's the same code running, and it's not a very big JavaScript output, I think. Let me check if we are using correctly DC. Yeah, we are using DC. With DCU full, you get like this. Let me check. This is the SIO example. Well, you get 500K, which also, of course, includes the whole like Heaps engine, and I think a few resources as well. I think if we are using resources, so we have maybe 200K of resources inside that. So it's not very big. If I zip it, it's back to 100K for the whole engine and the whole shader compiler and everything. So it's still a manageable size of code. It doesn't predict really huge binaries like mscript10 code or things like that. Other questions? Does HXL support advanced feature like GPU tessellation? Not at the moment. At the moment, HXL only supports vertex and fragment shaders, which are or pixel shaders, if you prefer this old term. We don't have yet geometry shaders, and not the fragment and not the other ones too. I'm planning to add them quite soon, maybe for our next project. Is not that much of work because I need to rethink a bit about how to integrate them into the workflow, but it's not really that much of work to add them. It's just a matter of looking at it and playing with it. I think the main limitation at the moment is that Flash doesn't support them. So, and we're moving definitely out of Flash for our next game. So at this moment we can look at using them at Shiro. You get a cordon in Linux Lime. Okay, I will report that to the people if you can debug using GDB and report on the thread. It's just the Linux Lime, the Lime support for Heaps is very recent, so I guess there might be a few bugs still. So please report them on the Heaps GitHub account so we can fix that. Has there any option to import sprite sheet generated by texture packer? Yeah, we have this. When you have a texture packer, you export either in an Atlas file, which I think is libgdx format, and then you get automatically, if you find an Atlas file, it will map to Atlas resources, which you can use get, and for instance, you can get a name, and it returns you a tile. Or you can use get contents and you get the world contents, which is a map with all your names, and you get a tile for. So you can use get animation, and it will return an array of tile, which is a format for animation. So basically, yeah, you get this kind of support. The resources we support right now are Atlas formats. They are bitmap fonts. They are font builders, images either in PNG, GIF, or JPEG. And we have a 3D model using FBX, and sounds in either WAV, MP3, or OGG. And tilemap, I think, yeah, tilemap is a level editor, tiled, so you can actually decode a tiled file using also this resource handling. And we have, of course, also like support for CDB levels, which are the CastleDB level editor, which I will talk maybe another day. So tell me more about Screen Inspector. Screen Inspector is something which we are working on it's a scene inspector actually. Basically, you can create. I will show a case again. I think it's in the basic example, maybe in the skin example. Yeah, that's the one we are using for. So if you compile your code with Castor, you can use this scene inspector, which is say that it will connect to CastorDB, which is another tool that runs at the same time, and it will enable you to actually inspect your scene, write your scene graph, modify all the properties of the objects, look at the shadows, look at the texture, render texture, a lot of different things from like CastorDB. And the neat things about it is that it uses some kind of jQuery and some kind of DOM. But the DOM, you have a virtual DOM running into your applications. Well, me, I can show you this while we're at it. I think if we compile here, let's say, yeah, it requires XSDL, but it's not. It's okay. So if I execute that, yeah, I say I cannot connect. I need to give him some kind of authorizations. That's something annoying. Let me check how I do that. Yeah, I cannot let him be that. Yeah, here. If I open with R, I can connect to a socket to CastorDB. And if I start CastorDB here, I get an inspector panel here, which is my 3D sense. So I can check, for instance, the skeleton. Well, let me show you a bit bigger. Here, I can see his name and I can move its property, for instance. This is not, yeah, this is a root. I can move this, okay? I can turn it invisible and I can inspect, for instance, for the skeleton, I can inspect this path and I can disable the lighting or the cooling changes to back or to front, which gives you some strange looking thing. So I get all the materials, all the things here, and they are still experimental. Basically, well, one thing that you can close CastorDB and open it later, and it still give you back to all these properties, because the code logic for the whole, like even the whole logic for this and the whole actually components is actually represented as a virtual DOM inside your application, which means you can add extra properties here. For instance, I can add here I add some, I think, rotation. Here is some custom thing. If I click me, it's open a new panel, and I can change here some rotation from my scene. And this is something entirely that I customize here. I had a new node rotation, and I can, okay. So I think that's interesting to be able to somehow have directly in your code logic have to be able to create UI to modify your engine while it's running. So we have not yet used it a lot. It's still something quite new in Heaps, but we are expecting to develop more these kind of tools at my company and in general to have support for some kind of like live editing for a lot of things, and be able to see what's going on in your game. I saw there is some networking code in the pull repository. Can you say something about that? Yeah, we have in Heaps, it's meant to be a complete framework for games. So we have some code for networking, using real-time networking, using TCP or UDP, and it's called network example, samples. I think it's not up to date, or it's using SVM. So it's in order to create real-time games, we have some support for like serialization of objects and binary serializations and real-time serializations, like incremental one. So here, for instance, we have a cursor that implements network serializable, and we're using this metadata to tag the property that needs to be like serializable. So it means that you can actually save this to binary formats, and it will save these properties, but not these ones. But it also means that when they get modified, they will be sent over the network, so they get synchronized in multiplayer games. So you don't just have to do that, and that's all you do basically. You first also establish a connection between a client and a server. So if I try to do that, I can compile this example. Maybe, yeah, it's okay. And I execute. And here I have two things open, and you see the first player is the red on the red thing, and the blue is the blue one. And you see there are two applications running side by side. So you see here, and it's only you get the log here. So it's only when it's modified that you get the properties get sent over the network. And you can also get RPC. So if I click, I play this animations, and it's a RPC call, so remote call. I just have to annotate this function as RPC, and when I call blink, it will make sure to forward it to the server. It gets executed on the server, then forward it again on the clients, so it gets executed on the client. So, well, I'm planning to write a lot of documentation on this soon, because it's something very new I've been working on the past months, and it's bringing you a lot of great things for networking. Well, it's actually not very tight to Heaps, so you could use that in any engine, I guess, because it's just a lot of macros for generating all the reflection code, and also I made sure it's very fast and very efficient. So I think it's an interesting thing. Oh, and I saw some CSS parsing rendering. Oh, well, this is something old, and I'm not planning to maintain this. We had the components set in Heaps in H2D comp, a lot of components for UI things, but we are definitely moving out of that, of having components, Heaps components, and instead using a CastleDB as an external editor to create our UI. We don't want anymore to have like complex UI running into the game. It's hard to maintain, it's always complex to edit, and really when it comes to creating UI, browser is maybe the best thing. When you have JavaScript and jQuery and a few plugins, it's very easy to create a complex UI, and very easy to edit and to modify and to skin. So we are not planning to, actually, we will maybe deprecate the H2D comp at some point, and maybe remove it entirely, H2D comp and CSS package from the distribution. Okay, I think I'm done with the question. We took a bit more than this time than the others. We cover a lot of topics. I hope it gives you some good overview of what Heaps is, what you can do with it. I'm sure you will have a lot of questions, so don't hesitate to leave the questions at the bottom of the video if you are looking either in streaming or in a recording, and I will make sure to answer them and eventually cover them in another video another day. Okay, thank you very much, and have a nice day.